Hello, so today I'm going to be doing the chemistry version B pretest. So I'm going to set up a timer for 20 minutes here. Okay, and I'm starting the timer now. Okay, so I'm familiar with these. Okay, so in the parent chain, we're looking for the longest chain. So there's 9 here. And yes, I recognize non as 9, and this is referring to 10, so I believe it's this one. So you're looking for the closest with these side chains, and this was the parent chain. So, and you want the one that's closest. So let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, so I think it's this one here. Carbon X and X, Z, Y. Okay. Oh, okay. I think it's referring to this branch right here. Oh, okay. Yeah, so we just have to count the number of carbons. 1, 2, 3. Oh, I can't remember. Is methyl, ethyl? Is it propyl and then butyl, or butyl then propyl? Mm, I think I'll go with propyl. I just have a gut feeling that it means free. Which carbons can only make one bond or more bond? X and Y, X and Z and Y. So X, Y, Z. Oh yeah, I think it's Z and Y because carbon can only make 4 bonds, and these already have free filled. So I'm fairly confident it's yeah, Y and Z. Which carbon is able to make 2 more bonds? Yeah, so I think that would be X, this one, and this one, but they're not labeled. Oh, okay, so they only give these options. Yeah, and it's not Y and Z. It's gotta be X. I forgot the international naming system. It's something like you gotta count 1, 2, 3, 4. So that's like 4 methyl, comma 5 propyl. Non-name. Oh no, but you need like the positions here, I believe. And like dimethyl. No, that's only if there's 2. Oh, so you don't even need these, I believe. Oh, but this format does not look right to me. It's not ring a bell. Yeah, let's move on and maybe this will come back to me. The addition of a methyl group onto carbon and would add an extra side chain. Oh, so I think it means like another one of these. So it would probably be like one of these three, or even these. I don't think it can be alpha because I would just extend the parent chain. So I think that excludes these first two. This one or epsilon. That'd be this one. It could be this one. I don't know if it can be epsilon either because it's just going to extend the parent chain. Yeah, let's go with this one. Okay. Which of the following molecules is not an organic molecule? Okay, organic molecules have carbon in them, if I remember correctly. So it's not carbon dioxide. Maybe something oxide. Chloroform. No, so this has got a carbon in it. Oh, this is like how the naming thing worked. Dichloromethane. Oh, so maybe it's like 4,5 methyl propyl nonane, something like that. We'll come back to it. Yeah, so this is the only one that strikes me that doesn't have a carbon, so I'll roll with that. How many valence electrons are present in methane? Now, methane is CH4, I believe. Let me try that out. So there's 4 bonds. So that means it's 4 times 2. Those are all of the electrons present that I can think of. Which element has the same number of electrons as methane has valence electrons? Oh, okay. So hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. Wait, hold on. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. So I guess has the same number of electrons as methane has valence electrons. So if they're an atom, then I guess it's got to be carbon. Oxygen. Oxygen's 8. Let me just check that one more time. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. Yeah, okay, oxygen. Which of the following functional groups is most likely to taste sour? Oh, I recognize this. Is that like some sort of like... I don't know, the only word that comes to my mind is acetic acid, but I don't think that's right. I'm pretty sure it's this one. It's something to do with like bases, maybe. This is just some extended group. Nah, I just have a feeling it's this one. Can your answer to the previous question participate in hydrogen bonding? Yes, because there is the COOH. Yeah, there's the OH. Yeah, I got. Which molecule will have the lowest boiling point? So lowest boiling point, which means weak intermolecular interactions. So it's not this. It might be this. This is quite a longer one. So it's got stronger. I forgot what the force is called. And this has a CL. So it's this one's strong. This one's also strong. This one's going to be stronger. So I'll go with this one. This one seems pretty weak. How many hydrogen atoms does an alkane with N carbon atoms have? Oh, I think those are like the rings, right? So let's see. 1, 2, 3, 4, 5. It's 1, 2, 3, 4. Oh, yeah, it's just got to be twice, I believe. Because if it's a ring, then all of the carbons are bonded together, and each one can only have room for 2 hydrogens. Okay. Dipole. I believe hydrogen bonding is a form of dipole. So it would be like the previous example with CCl, just like a strong attraction to this Cl instead. So let's just look for. So I see an oxygen here. That's a special one. This just seems like a ring with a methyl group. Yeah, something oic acid. This is an acid, I guess. Oh, maybe we can just use their boiling points. So this has a pretty low boiling point, so probably not. So I'm thinking it's this one and this one. So decanoic acid for sure. It appears here. Yeah, this one has to because there's an OH. Yeah, this one too because of the OH. I'm not too sure about diethyl ether. But I know it's not all of them because of this one. It's not this. Yeah, let's just roll with this. Assume each substance is a liquid at room temperature. Which of these molecules can mix with dichloromethane? Mix probably means the one with I'm not sure if it gets bonded or not, but this one strikes me as the odd one out because it doesn't have like the I forgot what it's called, but that bond, like the OH bond. So it's just stick with it. I'm not sure. This one's hard. Because it does not have OH or it does not have high electronegativity. Electronegativity. That was just a guess. I have no idea if that's the right word either. Despite that methanoic acid has much fewer carbon atoms than methylcyclopentane, its boiling point is much higher. Why? Oh, because of the hydrogen bonds. Where would you expect propanol to place in this list? What's propanol? Alcohol. I think it's an alcohol. Oh, so if it's an alcohol, it's got to be here, probably up between these two, because it's got hydrogen bonding. Or no, but it's even got free carbons, so it's a little bit longer. Let's go with between methanoic and decanoic. The addition of a methyl group to which carbon would not produce a molecule with a side chain. Oh, it should be A or Y, I think. Or maybe all of them. The addition of a methyl to which carbons would produce the same molecule. Yeah, I don't really understand what it's getting at here. How could it be the same molecule? Yeah, I don't know. Let's just guess. 1, 2, 3, 4, 5, 6. So 1, 2. Assuming there are hydrogens, this would be 6, 12. So it would be 2, 4. No. 2 hydrogens. So there's 8. Oh. 8, 7. 7. Okay, 8. 8 plus 1, 2, 3, 4, 5. 5 times 7. What the heck? 8, 15, 22, 29, 36, 43. That doesn't seem right. I feel like it should be an even number. Propyl groups, I think 2. I have a benzene. Benzene, I believe, is oh, it's the one where like the drawing can be like reversed with like the double bonds, but I don't know what that word. Let's just leave this for now because I have 8 seconds. Let's just guess this if it runs out of time. Yeah, okay, I ran out of time. So let's go ahead and submit this. $16 out of 25. Okay. So I'm just gonna review my answers real quick. Okay. Methyl ethyl. Not sure I see why that is. Oh wow, I was so close. Carbon dioxide's not organic, huh? That's strange. Maybe because there's no hydrogen? Yeah, I basically got this. Oh, 2n plus 2. 1, 2, 3, 4, 5. Maybe I'm misunderstanding what an alkane is. I'm not too sure on this one. Okay, glad I got this one. Yeah, that's what it was. London dispersion forces. Like dissolve like. Not sure. I didn't get this one right. But my point was like the same. It only has London dispersion forces because I noticed that all of these have like an OH and an OH. Those are dipole forces. Even this OC, I think. Okay, great. So 38. Let's see why. I just might have to study that later. Delocalized. Yeah, I'm not familiar with that. I wouldn't have gotten that. I didn't even get a chance to fully read this question. Yeah, I didn't know this. Oh, yeah. Actually, I did know this. It is polar. It's just a key there. I didn't get a chance to fully read this. Okay, so let's see what's next. Take a 5-minute break. So I'll pause the video now and I'll come back in about 5 minutes. Thank you. Okay, I'm back. So we're going to be doing the self-study for 30 minutes. So I started the timer. So we just have to Google these questions and type in -AI after. So I'm not interested in watching a video because I feel like that might take a long time. So let's go ahead and try this. Okay, so this is ringing a bell for me. Tetra. Um, I would say it's not very helpful for me because this is a very brief paragraph here, which is not like it's using substituent, which for a beginner may not know exactly what that means right away. And by an appropriate number and name is kind of vague. And in alphabetical order, like what is it referring to? I still want like a basic understanding, especially if I was a beginner. Prefixes, how do I apply these? So let's look more. Yeah, again, I'm not really looking for an entire video. Okay, this is a helpful first step. That's what I already knew how to do. It's not like a full step-by-step guide. Maybe let's try this website. So I've been reading this. I will say it's a lot of reading and quite intimidating as a student. You know, this is a okay. So maybe this table will be really helpful for me. So methane CH4. Yeah, it's not really helping me with the naming rules. Okay, maybe here's like a step-by-step guide. Okay, so you choose the longest chain. That's correct. Okay, so you pick the closest start. That's also correct. Yeah, so it's saying we start. Numbering begins on the right side. Yep. So 2,5 dimethyl octane. 1, 2, 3, 4, 5, 6, 7, 8. Great. That makes sense. Um, 7 carbon atoms. 1, 2, 3, 4, 5, 6, 7. Okay, I think I get the idea of it. Okay, this is a nice example. 2 bromo, 6 chloroheptane. So one thing that I would like to know is like the bromo and the chloro prefix. How did they like? Is there like a table where I could have all of those shown? Anyways, I think I should move on to the next question. Okay, that's helpful. Right away, it provides me with a response. Organic functional groups. This is a very key concept. Knowing like the alcohols. Um, so that's helpful. I'm gonna look and see if there's any more. Let's try the website they linked. Okay, great. I like that it provides a definition for what R is. That's helpful for reinforcing my knowledge. So again, I feel like this is kind of intimidating having all of them right here, and it might be a little time consuming to really like examine the differences between all of these. For instance, like yeah, alcohol and ether. Um, okay, I like that it provides like the names, like all for alcohol. Oh well, Tylenol. Oh, I didn't actually know that. Okay, that's a helpful definition. I learned what alkane was because I didn't know what that was before. And alkenes are with double bonds. Okay, great. Well, I like that it's hinting at aromaticity. That's like helping reinforce my knowledge of other learnings that I had. Let's go ahead and type this one in. Okay, great. I like that it provides the main free right there in bold, or highlighted rather. Yep. Okay, and that starts with weakest, middle ground, and then like the strongest, I believe. And a little description of each one. Let's see if there's any websites too. Hmm. That's an interesting analogy. But again, it seems like a lot of reading and like a lot of filtering for me to find what I'm looking for. This is kind of what I was looking for, intermolecular. How they have like the their charges there. Okay, great. I like that it's showing the different types of bonds, but I'm still not getting. It's quite slow for me to find like what I'm looking for. So this is the point I was looking for, and it's more than halfway down the page. Great, that makes sense. Dipole, dipole, that's important. Now I already am familiar with these quite well, so I'm not going to read into them too deep, but I will comment on how, if I were like unfamiliar with this, it would have taken me a long time to find this, which is quite inconvenient. Let's keep going here. Oh no, London dispersion forces, weird cases. Okay. Let's try this one. So it's not really giving me like specific examples. So it's talking about maybe like supercooling or yeah, I'm not really getting the point here. It seems like a lot of reading too. It's not really related. This would be a case where they're stronger, but I guess that would apply. It's not really looking for. I'm not really finding anything super specific. Yeah, and this would have to be an entire paper, which I really don't have time for. So I'll skip this for now. Okay, I'm quite familiar with this. Yeah, so I know this kind of well. And I think I also know this titration. I feel like this website's going to have a lot of reading, but we'll try it anyways. So this is quite like constituent. Reagent, titrant, burette. It's all like chemistry language, which I'm familiar with, but maybe like a beginner may not find particularly welcoming. Yeah, so it might be a little confusing and hard to understand it. Yeah, like analyte, quantitative. It's what is a simple definition, right? This is what I'm looking for. Okay, yeah, that's perfect. That sums it up completely. I could understand that. Um, but again, it took some time to find it, and the other websites are not as helpful. So, oh, okay. Well, this one was kind of straightforward. I think I got like a good answer for this. I didn't really find weird cases, so I have about a minute left. Sorry, I have to read this one a couple times. Okay, well, let's go ahead and try the practice questions. Pen. It's not 5-ane. Could be pen. I think it's pentane because hexane is Yeah, I'm pretty sure it's pentane. The lowest. Yeah, because these have single bonds, and then the ends have two extra. I remember this. The what was possible? Oh, okay. So esters and carboxylic acid. That would be in this website, I believe. So here they are. Oops. I think what they're getting at is a hydrogen bond there. So I'm just looking for maybe there's like um, a way I could find this answer, but no, I don't think it's this one. I don't think it's that one. I don't think it's this one either. I think it might be this one because they would be an opposite sweet versus sour, and yeah, let's go with that. London dispersion forces can be stronger than hydrogen bondings when the molecule of only London dispersion forces is sufficiently cooler than the molecule of hydrogen bonds. I believe that's what this was getting at. I believe it's cooler, but I'll come back to this one. Like colder. That's false. I remember it needs hydrogen as well. Can make a maximum of 4 and a minimum of this one I'm actually not sure about because maybe 0 bonds, just a floating carbon atom. Because it says theoretically, that's what I'm thinking. It means that it can apply. Alkenes, I remember, had double bonds. Yeah, this one I'm not really sure. Let's see if I can go back to an alkene website. This would be naming. This was functional groups, intramolecular, weird cases. Was titration? Yeah. Is it here? So now alkene has a double bond. Okay, alkenes are hydrocarbons with one or more double bonds. Common examples. Trigonoplanar. I'm not sure. I mean, the double bond. What does the double bond mean? Maybe water? Because in the, no. Um, yeah, double bond will make it bent. Um, like I said, trigonoplanar structure. And that might make it polar. I'm not really sure on this one. The presence of an acid can be tested for by adding cabbage and electrode, I guess. Maybe it would dissolve the cabbage. Um, well, this was actually weird. I think maybe an electrode, but I'm thinking that it's not going to create a current. Yeah, this one's actually also kind of hard. A base would just neutralize it, a water would dilute it. Cabbage, I mean, you technically could. Yeah, let's go with cabbage one on it. It'll be funny. Despite ethanol being smaller than butane. Ethanol, okay, this one, I know this one. Because it's an alcohol, right? So it has the its ability to participate in hydrogen bonding. Because butane's a larger atom, or sorry, like compound, but because there's only carbons and hydrogens, um, it only has London dispersion forces. While this one, of course, like it's an alcohol. So let's see if there's anything we can find about acids. Oh, maybe it's just referring to titration. But then you would need an indicator. I don't think it's a base because that would simply just neutralize it. And like if you don't have the indicator in the acid, then you can never tell when it becomes neutral. And I don't think it's water. It's just going to dilute it. Salt. It's not really going to do anything. I'm thinking it's like either an electrode because the electrode acids should conduct electricity. So maybe if the electrode works that way, like if you're able to see a current, then that would work. So I have 4 minutes left, but I think I'm ready to submit and check my answers right now. Let's go ahead and do that. Okay. Oops. Oh, because it could be like an alcohol. It could have an alcohol group on it. That's right. Yeah, I guess I didn't think hard enough of this one. Lowest, correct. Correct. Okay, that's interesting. Climate dispersion forces. Okay, yeah, that's obvious. I don't know why I didn't think of that. Um, I guess I got mixed up because it's something about cooled down and moving more slowly. I thought that it was referring to that, but I guess not. Um, this one has no correct answers. That's strange. But I think this one was right because it had to have hydrogens as well. Okay, I was unsure about this answer. A base, huh? Interesting. I'm not sure why. I guess I'll do more research as to. Okay, so I know this one now. This one, yeah, that was just my silly mistake. Um, yeah, I'll do more research on this one actually. Yeah, I was familiar with like an indicator. Oh, I guess you could add baking soda maybe. No, red cabbage juice. Yeah, this question was weird. I'm not sure about this one. Um, let's see about this one. Yeah, okay, I wasn't familiar with this one too. Oh, interesting. Okay, that's cool. Um, so I think I'm gonna move on. Okay, take a 10-minute break. So I'll come back in about 10 minutes. Thank you. Okay, so let's go ahead and get started with the post test. So I will be doing version A. Yes, okay, and I have 20 minutes, so I'm gonna set up a timer. Okay, the timer started. Let's get right into it. Okay, I'm not really sure what this triangle is about. Oh, I guess it's just a carbon ring. There are how many carbon? 1, 2, 3, 4, 5, 6. Let's go with 6, and it's a hexane. Numbering of this molecule will begin at. Yeah, okay, so if this is the entire chain, I believe it has to start at alpha because this is the closest. Yes. Okay, so this looks really familiar to the previous test. This is a methyl, and so there's definitely a methyl, and it looks like a 1, 2, 3 cyclopropyl. Yeah, that makes sense. Yeah, let's go with that because propyl means free, and cyclo means like circle. There is a type of branch that is common between carbon X and Z. What is it called? I'm assuming it's Y. I'm just gonna guess propyl because of free. 1, 2, 3. Unless it's referring to. the fact that there's 4 bonds on X and Z. There is a type of branch that is common between, maybe it's butyl, because it's not referring to like the branch in between them. I think it might be referring to the type of branching that's occurring at these carbon atoms, and I think they must be butyl because there's 4. Which carbon is able to make another bond? Y is maybe they're beta, but of course they only give us X, Y, and Z, so let's go with Y, which makes sense because these all have 4, so it has to be Y. Was the okay? So 1, 2, 3, 4, 5, 6. So it is a hexane. And then you have to start with the numbering. So 1, 2. So it's a 2, 2 dash methyl cyclopropyl. 1, 2, 3, 1, 2 ethyl, and that would be a carbon free. And let's keep going. 4. That looks like a dimethyl. Hexane. 2, 2, 3, 4 methyl cyclopropyl, ethyl, dimethyl, hexane. I think that's correct. The addition of a methyl group onto carbon would cause a change only to the name of the parent chain. Oh, I think so, just like extending it. Maybe this one here. I think that's straightforward. Yeah, if you put it on alpha, it would be either of these, changing all the numberings too. I'm pretty sure it's that one. Yeah. Tetrafluoromethane. Now, methane's got CH in it, so that is definitely organic. Tert butoxide. I'm not really sure what that one is. Hydrogen cyanide, HCN. I think this is not an organic molecule. Benzene definitely is. So I'm willing to bet it's this one because butoxide sounds like it's got carbon and hydrogen. How many valence electrons are in butane? So I'm going to draw it out again. I find it very helpful for me. So that'd be 4 carbons. And they would have... So the first one's got 8. And then the rest have 6. 6, 6. So it's 14, 20, 26, right? Which element, and this was, I learned this in the study session, so I'm glad I did. Which element has the same number of electrons as butane has valence electrons? Oh, okay. Sorry, it took me a long time there. How am I supposed to do this without a periodic table? I guess I just... 26? I don't think I have that many memorized. I'll just... Looks like iron. Okay. Which of the following is most likely to emit a sweet smell? I think it was this one if I remember correctly. I believe that was the carboxylic acid group. Yeah, COOH. Okay, great. Um, yes, because of the OH. Um, the OH. Yeah, I can just leave it there, I think. Highest boiling point, I think it would be this one because of the hydrogen bonding. Cl is not as strong as OH. Alkene, okay, so there's a little change in the question from last time. So it's got double bonds everywhere, or at least. Um, so it's got 1, 2, 3, 4, 5, 6, 7, 8. Huh. Oh, hydrogen atoms. Oh, I think that's just 2n, I believe, because it doesn't have the end, the two end ones, which would be the +2. Great. So the one that only has London dispersion forces would be the one that doesn't have like an OH or an CCl. So it's not this one. It's not this. Oh wait, no. I thought it was just which one only has London dispersion forces, but every single molecule is going to have them. Assume each substance is a liquid at room temperature. Which of these molecules can mix with water? So it would be the one that's polar, I believe. So ethanol definitely because of the alcohol group. Ethanoic acid, I'm not quite sure. Oh, it's right here. I think this one might be able to mix with water, but it'll just be like not as easy because it's quite big. 1-heptene, I don't think it can. So it's not these two for sure. I think it's this one because that's got the OH and this has also got the OH. Because both of the both ethanol and ethanoic acid have OH, which allows them to participate in hydrogen bonding with water. Cyclodecane does not have a permanent dipole. Its boiling point is much higher than ethanoic acid. Why? Okay, yeah, I know why. Because it's much larger. It's got 8 in this middle. This is like the condensed format, so it's actually very long, 10 carbons long. So it's yeah, this is like the learning like when can London forces be stronger. Um, it does. That's not true. That's not true. That's not true. Yeah, it's just because it's the biggest. Where would you expect methanol to place in this list? So again, methanol is an alcohol, and I guess it's only got one carbon. So methanol is small. It's smaller than this one, so I think it's going to be up here, above ethanol. Yeah, right there. Brilliant. Yeah, because this one's also got an alcohol group, but this one's a little bit larger, so it's got more London forces, meaning the IMFs are stronger. Okay. The addition of a methyl group to which carbon would not produce a molecule for side chain. I believe they would all. Because it's like symmetrical right now, and then if you add one hanging off here or here, yeah, this one I'm actually not too sure because I'm kind of rusty with the international naming system. So my thought is 1, 2, 3, 4, 5, 6. I think it would just produce one with a side chain. So I don't think it's going to produce the same molecule. But this question I feel is a little vague, so I'm not understanding exactly what it's getting at. Like, what does it mean by same molecule? Same as it originally was, which is not going to happen because you're going to add a methyl, or same as in, like, if you added at A, would it be the same as adding it at B? I think that's the second scenario. In that case, I think it would just be all of them. Actually, no, these two are next to each other. Yeah, this one I'm actually not sure about. Let's move on and maybe we'll come back to it. How many valence electrons? So there should be, I like to draw these out. So you got 3, 6, 9, 12. Six, 30, I think. What is the maximum number of propyl groups? Two, maybe? Because there's two hydrogens at the moment. I'm not sure if that'll mess up the structure, but let's see how many questions are left, because I got 3 minutes. Okay, I think I can finish. The electrons in a benzene model are not fixed to 1. Oh. I remember was it like dislocated or something? I I remember it was like a cloud, but I didn't really pick up on the specific word. I'm forgetting it. Um, Something like that. Um, this does not make sense. You cannot get a pH past 0. Yeah, I guess you would have to titrate it. You could detect. Yeah, I'm not really sure of this one. I'm thinking it's not the orange dye because it doesn't really do anything as like an indicator for acidity. Water will just dilute it, and it's non-polar, so it's not going to dissolve it. So this rationale is incorrect. This doesn't make sense. So this is the only one that remains for me. So I have a minute left. I want to go back to this question. I think these are correct. I'm just a little unsure about these two. And I'm a little unsure about this wording too, but that's the only thing I can come up with at the moment. So I think I'm out of time. I'm going to submit it now. And this timer. Let's go ahead and view the score. Oh, yeah, it was referring to this. Yeah, okay, I just didn't understand that question. That makes sense now. This was just my trimethyl. I think that I didn't have enough time to read into these examples. I'm not really sure about this one. Maybe like the ester group. Okay, that's correct. Delocalized. Okay, yeah, that was a word. I just didn't remember it correctly. Okay, overall, not too bad. Thank you very much.